Assalamu alaikum warahmatullahi wabarakatuh. Dear student of third secondary, today we are going to complete our videos for solving Egyptian Knowledge Bank. We have Nagwa platform. We start with lesson 1, hydrocarbons, and today we are going to illustrate or giving questions for lesson 2, structural isomers. Okay, we will start with 15 questions in this video and we will complete the other 10 questions. So we have 25 questions for this item, structural isomerism. Okay, let's start with our questions today. Question 1 says that which of the following structures is not a functional group isomer of C3H6O2? Okay, we said we must have a functional group. We will start with here we have C double bond C, we have C double bond O, we have here C double bond O, CH double bond O for aldehyde, C H COH here for aldehyde also. So we want the one that is the wrong for this, not a functional group isomer for this one. Okay, if we said it's a not functional group, means that in case of carbon compound or the carbon between or the bond between the carbons, C double bond C here, this one away from the functional group. We want structure, not a functional group of isomer here. So if we have here C double bond O, OH, so we have a carboxyl group. Here is a carboxyl group. So the bond between the functional in the carbon here also C double bond O for ketone, CHO for aldehyde, here CH, COH, okay. So all of them with a functional group, but we have only one that the bond between the carbons only without the functional group. Here neglecting the rest of compound containing functional group with also here, but the carbon alone between them, so it's not functional group isomer for this one. We have the answer will be letter E. The answer will be letter E here, as we have the functional group C, not a functional group. It's a bond between only two carbons, C double bond C here, with branching H to H and H here to complete the bonds between them. So the right answer will be here, letter E. You must concentrate and focus for the bonds between them. Okay, I think it's some difficult questions. You have to concentrate before you answering it. Okay, let's go to question 2. Question 2 says that considering correct nomenclature and isomerism, which of the following is not correctly named structure? Isomer of C3H6Cl2. Okay, we will have 3 carbons and 6 hydrogen and 2 chlorine atoms. Okay, if we consider that, we have all of them are structural isomer. As if we write this one, we have 3 carbons, propane, meth, eth, propane, and from each atom, okay, we have from the carbon number 2 we make a branching, so it will be dichloropropane. Here we have also propane, 3 carbons arranged, and in each one, in the carbon 1 and carbon 2, we have dichlorine. Also number C, we have here dichloropropane on the first carbon. From the left we have 1 and 1 dichloro. Okay, all of them are structural isomers. Also we have here Dichloropropane. Dichloropropane, we have 2 and 3. 2 and 3 dibromo. Okay, we have here 1 and 3 dichloropropene. Dichloropropane. We have 1 and also 3, both have 2 carbon atoms. But the different one here, that it's not a structural isomer, as we have dichloropropane 2 and 3. If we arrange the chlorine in the 2 and 3 carbon atoms, they not make a structural isomers, as it will not giving this one or making the structure as it is the main structure of carbon. Main structure of carbon making a straight chain, it will affecting it, and so the right answer will be not correctly structural isomer, will be letter D, 2 and 3 dichloropropane. 2 and 3 dichloropropane. Let's going to question number 3. Question number 3 says that how many isomers are there of C7H16 according to the number of carbon atoms. Okay, so if we calculating it according to the number of carbons, the rule that giving the number of isomers that we have will giving doubling or increasing by 2 for the carbon atoms. So we have here the number of isomers will be 9 isomers for this compound. Okay, we will have 9 isomers for this compound according to the rule that giving before. We have 9 isomers for C7H16. Okay, let's going to question number 4. Question number 4 that says that what type of isomerism is accepted by the 3 compounds in the diagram? We have here, if we calculating the number here without calculating the number of carbon, okay, we have OH group here, OH group here, OH group with different positions, without any focusing or making any arrangement or calculating number of carbon. And also we have a functional group OH with different position, one time on carbon 1, one time on carbon 2, one time on carbon 3. So it's a different position for the functional group here. So the 3 diagrams compound giving different what positional isomerism. The right answer here will be choose letter D, positional isomerism. So let's going to question 5. Question 5 says that which of the following is not a chain isomer? Not a chain isomer. I think it's maybe easy. We have C6H14. C6H14. Okay, not a chain isomer means that make not a branch, not a chain isomer, make a branching for it. We have 2,3-dimethylbutane, 3-methylbutane, 2-methylbutane, 2,2-dimethylpropane, and 2,2-dimethylbutane. Okay, if we discuss at first, not a chain means we have less number of the carbon in the compound. Okay, let's discuss. We have here 6. Here we have the least number of carbon. We have hexane. The previous number will be pentane. Okay, let's mention that we will decrease the number of carbons as much as possible. For making a chain, we will decrease the number of carbon for the straight chain. The chain here, we must have 5 carbons. If we decrease the number of 5 carbons less than 6 as hexane, so we will make a branches, more number of branches. So if we have meth eth prop but benta, we have five here, five. So all of bentane will not giving a branching. Okay, they also a chain isomer. Butane also giving a chain isomer. But if we decrease the number to 3, meth is proof, so we will have a chain, not a chain. We will have branched isomer. We will have branched isomer here. So we have 2,2-dimethylpropane. 2,2-dimethylpropane as we giving least number of carbon atom and the others making a branching. So it will not a chain isomer, it will be a branched isomer. So the right will be here letter D, 2,2-dimethylpropane. Okay, let's discussing question number 6. Question number 6 says that which of the following hydrocarbons is not structural isomer of hexane? Okay, if we discuss hexane, it means that is a saturated compound. So all chains must be, in case of saturated, not a cyclic, as if we discussing the classification of hydrocarbons, we will have the one making cycle, it will be unsaturated here, as we said, all branching or all structure isomers must be here chain, okay, or branching, but not a cyclic, not a cyclic, making it unsaturated. So structural isomer here, all are branching here or making a side branch or positional branching, but the one cycling here not a structural isomer of hexane, as it will giving it a cyclic one. So the right answer will be letter B will be the right answer for this question. So it's not a structural isomer of hexane. Question 6, the right answer will be letter B. Okay, let's go to question 7. Question 7 says that 1 chlorohexane, 2 chlorohexane, and 3 chlorohexane have the same molecular formula, C6H13Cl. What type of isomer is exhibited between the three compounds? Okay, we said we have different placing for chlorine on the hexane compound. Okay, we have 1, 2, and 3. We make a different position for the chlorine atom on the hexane molecule. So I think it's easy question. This is one easy one only. We have here chain geometric functional optical and positional isomerism. So the right answer will be letter E, positional isomerism will be the right answer for this question. I think it's easy one. Let's go into question number 8. Question number 8 says that what is the common molecular formula for the following collection of molecules? We have here the all of them have carbon atoms. We will take one. We have one here, carbon 1, 2, 3, 4. We have 4 carbon atoms, and hydrogen we will counting it 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 8 hydrogens and we have only one oxygen. Okay, we have here 4 carbon, 8 hydrogen and oxygen. So the right answer will be letter D. Okay, C4H8O. Okay, we counting all of them. We have here also 1, 2, 3, and 4 carbons, 1 oxygen here, and hydrogen 1, 2, 3, 4, 5, 6, 7, 8. Okay, we will counting the chain or the dash that we have in the drawing. So all of them have in these six collection of molecules have the common molecular formula C4H8O. Okay, let's go into question 9. Question 9 says that complete the following structural isomers are molecules with. I think it's easy. From the definition, structural isomers, they are, all of them are different in the structural formula. So the structural isomers, if we make choosing for it, we have the same skeletal formula, not different molecular formula, no, same structural formula, no, and same displayed formula, also no. They are different structural formula. Yes, this is the right answer. Letter E, structural isomers are molecules with different structural formulas. Okay, let's going to question 10. Question 10 says that which of the following molecules is a positional isomer of C4H9OH? Okay, if we have positional isomer, means that the functional group of it OH make a position in the carbon, in the main carbon, not in the branched one. Okay, here we have OH, but in the branched carbon, here we have C double bond O. No, there is no OH alone here, positional for isomer. Here we have C double bond O. We want the group OH alone. Here we have CO. We have ether here, not one of the positional isomer. And the last one here we have carbon make a long chain, and the positional group OH, phenyl group here we have structural, or sorry, positional isomer on that chain here on the main chain OH. So the right answer will be letter E, as we have the positional isomer here. We have OH on the main chain of the carbon, or the main skeleton of the carbon that we have. Okay, so it is positional isomer of C4H9OH, as we have OH on the main carbon skeleton, making a functional group OH or phenol. Okay, let's go into question number 11. We have question number 11 here. Question number 11 says that which of the following molecules would you expect to have the lowest boiling point? As we mentioned, any compound that we have a straight chain, it will be having high, long, or large, or big boiling point with the longest chain. And also here with longest chain, one branch, longest chain with one branch. Here is a longest chain, but we have branches on different, what, on different carbons. The one that giving the lowest point will be one making a high branches or big number of branches. And also in opposite side we have the, on the same carbon, it will decrease the van der Waals force connecting between the carbon, or between the molecules together, for making a whole number of, or large number of molecules to join together by a van der Waals force. So here we have opposite on the same carbon, that making it lowest boiling point. So the right answer for question 11 here will be letter A. We have a branch here, two methyl groups, making it having a lowest boiling point. This is the main point, as we have here longest chain, but branch on the both sides make it difficult to connect the molecules together with each other by a van der Waals force, making it with the lowest boiling point. Okay, this is the answer for question 11, letter A. Okay, let's go into question 12. Question 12 says that which of the following molecules is that chain isomer of C4H10? Okay, we have here the isomer. We want a chain isomer for C4H10. Okay, we have straight chain for 3 carbons, mis is prop, and one chain for, or make the branches for the other. We have here the chain isomer of C4H10. We have here 3 carbons connecting together, make a branch with a methyl group here. So the one making a chain isomer here will be what if we calculating C4H10? Here we have C5, here we have C4, but we have oxygen. Here we have C5, here we have C4, but it will not a chain, it will all of them is a branching. Here we have a chain main 1 2 3 and the branch methyl group from it. So the right answer will be letter E. The right answer will be letter E. A chain isomer of C4H10 will be letter E. Letter E is a chain isomer, as we have the main chain here, all of them on the straight line, and we have branch methyl group from it, as we have C4H10, 3, 6, 9, and 10, making 10 hydrogen atoms. Okay, let's going to question 13. Question 13 says that how many structural isomers are possible for pentane? Okay, if we said pentane, we will have 5 carbons, and we will decrease the number of carbons by 2 minus 2. If we have a carbon 5, so it will giving possible structural isomers that we have less than the number of carbon atom by 2. So the possible structural isomer for pentane will be what? Will be 3 structural isomers for pentane, as we have 5, C equal 5, N equal 5, so it will be N minus 2. So we have 5 minus 2 will giving 3 structural isomers. Okay, let's going to question 14. Question 14 says that how many positional isomers does butene have? Does butene have? Okay, so we have here butene, mis is propute. Okay, butene here that we have 4, but we have 2 carbon atom connecting together by a double bond, so it will have here 4 carbon atom. Also minus 2, we have 2 positional isomer. We have 2 positional isomers. So how many positional isomers does butene have? If we have 4 carbon atoms, 2 of them connecting by a double bond, and so minus 2, N minus 2, 4 minus 2, giving 2 carbon atoms. Okay, so the right answer will be letter C. 2 positional isomers of butene will having the right answer. Okay, so the right answer will be letter C. Okay, let's going to the last question of our group today, question 15. Question 15 says that complete the following. Functional isomers are molecules with, okay, we said its definition here, all of functional isomer molecules have the same molecular formula, as all of them have the same molecular formula. So we have here all of them right, but different in what? But different in the functional group. But different in the functional group. We have one of them have ketone, one of them have aldehyde, one of them have ether group, one of them have carboxylic group. So we have here the right answer will be letter B. It is the right answer. All the functional isomers are molecules with the same molecular formula, but at different functional groups. We have different functional groups connecting them together. So it is the last question of this part of the structural isomers. We will continue the second part of this question or this lesson. Okay, I hope you enjoy this part of questions. Thank you, goodbye, and good luck.